Let's talk about Project 2, Angle Bisectors Part 2, which corresponds to the third day of the project, or Lesson 8. So I am actually looking at the image that goes with question 2. Now there is a question 1. It corresponds to the stuff you did for lesson 7, the stuff you did yesterday. So hopefully that should be pretty straightforward for you. You're asked to reload your web page that you used yesterday with that tool and repeat the process of constructing an angle bisector using those same instructions from yesterday. And once again, you're asked to construct that angle bisector, press done, and copy and paste the code. So again, that's just carryover from what you did yesterday. Now today, again, I'm looking at question 2. I've only pasted the image on the screen here just to conserve space, so I'll be reading the directions out loud. It says that, let's see, practice constructing more angle bisectors in the tool or by using the instructions at the bottom of the Lesson 8 webpage. When you're confident that you can construct angle bisectors correctly, you're ready to explain how the tools were used to successfully construct the bisector. So we're asked to review this construction that I'm showing you on the screen, which was completed with that interactive tool. It says that line segment AH is constructed as an angle bisector of angle CAB. So let's take a look at that. So AH, which is here to here, oops, it's not a very straight line, here to here, right? So there's my AH, is an angle bisector of CAB. So I'm just going to outline those as well. Again, just to kind of help me see what we're talking about. So I know my lines are a little crooked, bear with me. So we're saying we've got this larger angle, CAB, and that red segment is an angle bisector. So in fact, what I might even do, and I'm going to do it way out here because there's a lot going on closer in, I'm just going to draw like kind of little dotted angles here, and I'm just going to put a mark through them, and that's going to remind me that these two angles that I've just outlined have the same measure, because by definition of an angle bisector, that's what's happening. That means that this angle bisector, that segment in red, has kind of cut my angle in half, more or less. Okay, so that's what I know so far. And then it goes on to say, let's assume that we connect points E and H, which again, I'm just going to do this as they explain things, and I think that's the easiest way to keep track of stuff. So let's assume that we connect points E and H. So here's E, here's H. Assume that we connect them with a straighter line. That wasn't bad. And also points F and H. So here's point F, and here's point H. Okay. So now I've just created a line segment EH and a line segment FH. Now to prove that AH, my red line, is that angle bisector of BAC, we can first show that triangle, I'm going to need more colors here, that triangle AEH, so you can see AEH, in fact I'm going to shade it in. Where's my highlighter? So you can see that by connecting E and H, I've kind of created this triangle in here, right? So we can first show the triangle AEH is congruent to AFH, and that's just that other triangle in here. So let's review again what we've said so far, because I've been kind of color coding and stopping and going as we've gone along. So let's see where we're at. We're claiming that AH is an angle bisector of angle CAB, and then they said assume we connect points E and H and F and H to create these line segments. If I wanted to prove that AH, my red line, was an angle bisector of BAC, I would show, one way of doing it, they're saying, is that I could show that these two triangles are congruent, the two that I've highlighted, my yellow triangle and my orange triangle. Because using the definition of congruent triangles, I can show that corresponding parts are congruent. And the reason that that matters is that the angles in question for my angle bisector, remember, we're kind of like backtracking and explaining why this is an angle bisector. So remember, these are my two angles. I've got an angle HAB and CAH. I'm talking about these two angles, and I'm saying, well, how do I know that AH is an angle bisector and that it has split these into two equal measure? And I'm saying that because this triangle in yellow and this triangle in orange are congruent, which means that their angles are also congruent and therefore have equal measure. So this angle EAH right here must be congruent to this angle, we'll call it HAF right there. So those must be congruent. So if those are congruent, then I do know that AH is a bisector for angle CAB. So I know that was kind of a lot, and all of that is given to you, right? So I'm just explaining that, and none of that was left to you to figure out. That's just the explanation that they give you, so hopefully that clarified. Their question to you is regarding the tools they use to construct this whole thing. And they say, let's talk about the circle with center through point tool. Circle with center through point tool. So review that if you're not sure what I'm talking about. But the image for it is literally just a circle, I think, with a little dot in it. So that's circle with center through point. And they want to know, why do you think we use that tool to construct circle A? So now we're talking about this large circle A. You can see here's the A. So this is it, this biggest one here. So why did we use that tool is their question to you. So we're relating it back to that whole discussion we just had about this line segment AH, our segment in red, being a bisector for angle CAB. And they're saying, why was it important that if, that being our end game, why was it important that we drew the circle using that tool? So think about the explanation that I went through. We drew line segments EH and FH. We kind of talked through why the triangles were congruent and all that good stuff. So why did it matter that I drew this circle that way? Consider your answer options. They give you to show that AE is congruent to AF, these two line segments, to show that EH is congruent to FH, to show that IE is congruent to IF, and to show that angle IEA is congruent to angle IFA. So which one of these things was I able to show by drawing the circle with that construction tool? Consider what the point of this image was and what it was demonstrating with that angle bisector, and which of these would really be the most crucial. And remember, we're talking about what this circle establishes. So it's not whether or not these claims are true, it's which one of these was I able to show by constructing my circle that way. Now question 3 plays off of that as well. I've already kind of muddied up this picture, but they kind of reiterate what we just said, with all my color coding and line segment drawing and talk of angle bisectors. They reiterate that, and then they ask, two congruent circles are drawn with the compass tool, and they're talking about circle E and circle F. Let me highlight those for you. Circle E and circle F. So E and F, so these two smaller circles, were drawn using the compass tool, which shows a circle with a point through the center and a line from that point to the circle, and a line segment below the circle. And they say two congruent circles are drawn with that tool, and this is done to show that segment blank is congruent to segment blank. So again, consider the point of this whole drawing, which was to be able to conclude that AH was a bisector for angle CAB. So what is relevant to that, and then also what is relevant to these two circles in particular? Now I know I'm being a little bit cryptic here, but that's about as much as I can tell you without giving it away. But again, consider what's important to the overall point of this image and that proof, and what's important to those two circles in particular, and hopefully that'll give you a clue as to why they drew those two circles in that way using that tool.